Hi everyone, we're going to work on example 4 from 1.8 and actually I think 5 and 6 also maybe. I don't remember exactly how I have this numbered. But because watching me do the first part, number 4, is really boring, I've actually already filled it in, so it's kind of hidden right now. So as usual, if you want to pause and work through as much of this as you can, that's great. I know it's not super exciting, but crunching through a couple of these integrals would just kind of make it really click what we're actually doing here. So we have on this first page some integrals to crunch through. And basically what I'm doing is each one I'm integrating sine squared t. And I've deliberately chosen that function because that's not a particularly nice one to try and integrate by hand. It's possible, but it's certainly not something I think we're just going to guess our way backwards out of right now. Especially not without either some trig formulas or some integration by parts. So I've taken this integral of the sine squared function, and notice on every single one I'm starting at 0, but my upper limit is changing. And as I increase my upper limit, what you can see is I start with no area. So the area under sine squared from 0, 0, 0. The area under sine squared from 0 to pi over 6 is a little bit more than 0. And then if we go from 0 to pi over 3, it's a little more than that, and so on. So I have done nothing but change the upper limit of integration in all of these. So I just want you to, if you haven't already, pause, look at this for a second, just think about it. I wouldn't expect you to crunch these by hand, so this is really just an exercise in can you plug these into your calculator and figure them out, and just connect with what we're actually doing here. Okay. So next page, that's really all I have to say about that page. The next page is where it gets interesting. Now I want to consider the function g of x, and I'm going to define it in a really new and weird way. I'm going to say that this function inputs an x value and makes it the upper limit of integration. So for example, g of 1 would be the area under sine squared t between 0 and 1. Notice that this is exactly what we just put work into on the last page, was finding values of this function. So I could go back up here and say, okay, according to this new definition I made, this is my g of 0, this is my g of pi over 6, and that pi over 6 is coming from right here, this is my g of pi over 3, and so on. So I want to, on this very first grid, plot the points from that previous page and see if I can get a rough idea of what g looks like. So I know the first one was 0, 0. I know the second one was pi over 6 and then something really little, 0.045. And then we go up to about 0.3 and then almost 0.8. So this is 0.5. Let's see if I can not make a mess. Sorry, my phone keeps beeping. Usually no one wants to talk to me, and then whenever I do something quiet, everyone wants to talk to me. Okay, so what did I say? I think I said 0.3, which will be a little below that, and then 0.8, which is going to be a little above that. I really wish I had a grid right now. And then 2 pi over 3, 1.26, and then a little over 1.5, 1.26, a little over 1.5, and then the last one is a little bit more over 1.5, not very much, a little bit higher. This point might be a little crooked, but I think it'll work. Okay, so here's my points, and if I connect the dots, I do get a general idea